I want you to imagine an alien life form. It is yellow. It is slimy. It moves by pulsing. It can grow to the size of a meter. If you cut it in half, it doesn't die. It becomes two separate entities. And if those two entities meet, they fuse back together and share their memories. You don't have to look to space to find this. You can find it in your backyard. This is Physarum polycephalum, the many-headed slime. It is not a plant. It is not an animal. It is not a fungus. It belongs to a kingdom of life called protists. It is essentially one giant single cell with millions of nuclei floating inside it. For decades, scientists ignored it. It was just slime. But recently, researchers began to test it, and what they found broke biology. They put the slime mold in a maze. They put food, oat flakes, at the entrance and the exit. The slime mold grew into every corridor of the maze to explore. But once it found the food, it did something incredible. It retracted all the dead-end paths. It shrunk its body down to a single thick vein connecting the start and the finish. It found the shortest mathematical path through the maze. How does a blob of jelly solve a geometry problem? It has no brain. It has no nervous system. It does it through pulsing. The slime mold pulses like a slow heartbeat. When a part of the slime finds food, it pulses faster. This pushes fluid into that area, expanding it. When a part finds nothing, it pulses slower and the fluid drains away. It is a biological computer. It processes data using fluid dynamics instead of electricity. It is physical intelligence. The maze was just the beginning. Japanese researchers decided to give the slime mold a harder problem, a civil engineering problem. They took a map of the Tokyo area. They placed an oat flake on every major city. They placed the slime mold on Tokyo Central Station. They let it grow. At first, the slime exploded outward in a chaotic web. But over 26 hours, it refined itself. It strengthened the connections between the major food sources and abandoned the empty spaces. It built a network of tubes. When the scientists overlaid the slime mold's network on top of the actual Tokyo railway system map, they were identical. The slime mold had recreated the Tokyo subway system. But it gets better. The slime mold's version was actually more efficient. It used less track to connect the points, and it was more resilient to damage. Think about that. It took human engineers decades, millions of dollars, and advanced computers to design that railway. The slime mold did it in a day, just for lunch. This experiment has been repeated with maps of the USA, the UK, and Spain. Every time, the slime optimizes the route perfectly. Archaeologists are now using slime mold to map ancient Roman roads. They put food on the known Roman cities, let the slime grow, and the slime shows them where the lost roads should be. And when they dig, they find them. Intelligence requires memory. You have to remember where you have been to know where you are going. But the slime mold has no brain to store memories. So how does it navigate without getting lost? It uses an externalized memory. As the slime mold crawls, it leaves behind a trail of transparent, non-living slime, like a snail trail. Scientists discovered that the slime mold is repulsed by its own trail. It will not cross a path it has already explored. The trail acts as a do not enter sign. It is outsourcing its memory to the environment. It writes its history on the ground, so it doesn't have to keep it in its head. This is a profound concept. Humans do this too. We use notebooks, we use computers, we use libraries. The slime mold proves that you don't need a brain to remember. You just need a system. But can it learn? Scientists tested this by blowing cold, dry air on the slime mold at regular intervals, every hour on the hour. The slime hates dry air, so it would slow down its growth. After a while, the scientists stopped blowing the air, but the slime mold still slowed down exactly on the hour. It had learned the pattern. It was anticipating the future. It had a concept of time. A blob of yellow goop was predicting the future based on past experience. That is the definition of learning. The slime mold forces us to ask a difficult question. What is intelligence? We usually define intelligence as being like a human. We look for brains, we look for neurons. But Physarum polycephalum proves that intelligence is a fundamental property of life itself. It is cognition without a cortex. This has massive implications for AI and robotics. Scientists are now building slime mold computers. They are using the slime to solve complex mathematical problems, like the traveling salesman problem that stumps supercomputers. They are building soft robots controlled by slime mold pulses instead of microchips, and it changes how we look for aliens. We look for radio signals, we look for cities. But what if the dominant intelligence in the universe isn't a humanoid with a big brain? What if it is a planetary-scale slime mold? A massive sentient ocean of goo that covers an entire world, solving problems, building networks, and thinking in slow, fluid pulses. We wouldn't even recognize it as alive. We would just step on it. The slime mold teaches us humility. We are proud of our brains, but we are just one way to solve the puzzle of survival. The slime has been solving puzzles for 1 billion years without a single thought. I am your host. Watch where you step. Subscribe.